Welcome to the ReGenX Generator demonstration video. In this video, we're going to be demonstrating a conventional generator which operates at less than 100% efficiency. And we are going to be showing the conventional generator coil, what happens when it's placed on load. We'll be demonstrating the load current sine wave for the conventional coil on the oscilloscope. And then we will be demonstrating the ReGenX generator. I should mention that with any conventional generator, whenever you take power from the generator, electric power from the generator, the equivalent amount of mechanical power must be returned to the generator in the generator's drive shaft. The ReGenX generator, the requirement for that increase in mechanical input power to the drive shaft to be supplied by the prime mover is a result of generator armature reaction, which is a counter electromagnetic torque that is produced around the conventional generator coil, which performs negative work and resists the rotation of the rotating magnetic field, the generator's rotating magnetic field. So we'll be demonstrating conventional generator operation, conventional generator, generator armature reaction. We'll be demonstrating the prime mover increase that's required when the conventional generator is placed on load, and we'll be demonstrating a generator that is operating at less than 90% efficiency in its conversion of mechanical input power to electric output power. Then and we'll be starting our demonstration at rotational equilibrium, which means that the net power in the drive shaft is 0. So then we will be demonstrating the ReGenX generator. And the ReGenX generator operates at infinite efficiency, which means that 0 mechanical input power is required when the ReGenX generator is delivering power to the load. And this will be evidenced by a 0 prime mover input power consumption when the ReGenX generator is placed on load, and actually a slight decrease in the prime mover input and a slight increase in the speed of operation. So in the conventional generator operation, we will be delivering about 8 or 9 watts to the load, and we will notice approximately a 20-watt increase in the prime mover's input consumption when the conventional generator coil is placed on load. And when the ReGenX generator is placed on load, we'll be delivering almost maybe 10 or 11 watts to the load, and we will not see a increase in the prime mover input consumption. And again, the conventional coil will be operating at less than 90% efficiency, less than 100% efficiency, and the ReGenX generator will be operating at infinite efficiency. So I'll turn on the prime mover. We'll bring the system up to rotational equilibrium, and then we'll start our test. I should also mention that the ReGenX generator, it has a is US patented. It was originally validated at MIT in 2007, and the backing theory was developed in the Power Lab at Ottawa U from 2008 to almost 2011. So our system is currently on no load. The no load speed is 3,482 RPM. The power to the prime mover is 160 volt amps, and we are currently on no load at rotational equilibrium. And the first thing that I will do is place the conventional generator coil on load so we can establish what happens in our prototype with conventional generator operation. The voltage and the current across the load. So when the conventional generator coil is placed on load, and when it delivers about 9 watts to the load, the input to the prime mover increases by 20 volt amps, the speed decreases, and we can see the load current sine wave for the conventional generator coil on the oscilloscope. So now I'm going to put it back into no load again, and then I will place the ReGenX generator on load. So we're at rotational equilibrium again. Our system speed is 3,483 RPM. The power to the drive to the prime mover is 161 volt amps. We're at rotational equilibrium, and the mechanical power in the drive shaft is 0 watts. Now, what we're looking for with respect to infinite efficiency is we want to make sure that the power to the prime mover does not increase. That means that no additional mechanical input power is being delivered to the generator's drive shaft. And since we are at rotational equilibrium, and we know that at rotational equilibrium, the mechanical power in the drive shaft is 0 watts, we will also know that the mechanical power in the drive shaft when the generator is on load, if the prime mover consumption doesn't increase, then we know that the drive shaft power is still 0. So again, 161.5 volt amps to the prime mover. So we started on no load with 161 volt amps to the prime mover, and we're delivering a little over 9 watts to the load, and our input to the prime mover has gone down from 161.5 volt amps to 158.2. If the input to the prime mover stayed at 161.5 amps, that would be infinite efficiency generator operation. However, what we're doing with the ReGenX generator is we are reversing the counter electromagnetic torque that's produced around the conventional coil, and we are producing a complementary electromagnetic torque. So what this means is that electricity can now be generated with 0 watts of mechanical input power, 0 financial cost in the generation of electricity. The generation of electricity can be produced with 0 pollution and 0 CO2. In the application in electric vehicles, because the generator armature reaction, the counter electromagnetic torque, is reversed and a complementary electromagnetic torque is produced in its place, this lends itself to electric vehicle operation, whereby the EV can recharge its batteries while it's driving without the negative effects associated with regenerative braking. So once again, we are on no load. The input to the prime mover on no load is 160.4 volt amps. We are at rotational equilibrium, and I'm going to place the ReGenX generator coil on load again, and you will be able to see the load current delay for the ReGenX generator coil. The blue load current sine wave on the oscilloscope is the load current sine wave for the conventional coil, and the yellow load current sine wave is the load current sine wave for the ReGenX coil. Both coils that are in the prototype are connected to an identical load, which is purely resistive. The power factor of the load is 1. So essentially what we're looking at is the current and voltage, which are in phase in both coils. And the load current sine wave for the ReGen-X coil is currently, it's about 50 degrees. And it can be increased to as much as beyond 90 degrees, which I'll demonstrate now. So now we can see on the oscilloscope that the load current sine wave for the ReGen-X coil is delayed by more than 90 degrees, and we have produced a slight additional reduction in prime mover consumption and a slight increase in system speed. So once again, the ReGenX generator operates with a 0 watt. The ReGenX generator generates electricity with 0 mechanical input watts in the drive shaft, and the counter electromagnetic torque that's produced by the conventional coil is reversed in the ReGenX coil, and a complementary electromagnetic torque is produced, and which allows us to generate electricity with 0 mechanical input power. And it also allows us to produce electric vehicles which are capable of regenerative acceleration, which means that when the generator is recharging the batteries in the EV, it is not slowing down the electric vehicle. In fact, it is accelerating the electric vehicle. Thank you for taking the time to watch this video. Cheers.